Okay, so what I want to do right now in this video is go over some of the theory that about functions on page 1 of the chapter 1 notes, along with example 1.1.1. So we worked with functions earlier today in class, and as I mentioned, the values that you can plug in to a function, if you put them all together, is the domain. Now what happens in a function is you'll have some values in the domain. For example, you might have the number 1, you might be able to plug in the number 2, the number 3, and each of those values gets sent to another value. So for example, if my function, give me 1 second, sorry about that. For example, if my function was f of x equals 2x, then when I plug in 1, I get 2. When I plug in the number 2, of course, I get 4, and so on. Alright, now these numbers over here, whatever these outputs are, this is called the range. And so you're going to hear those phrases a lot. Domain is the values that you can plug into a function. The range is the values that are spit out at the end of the function. Okay, now it's important to know that not all relations between two sets are functions. So let's look at example 1.1.1. Which one of the following is not a function? Notice that in a function, in each function, for each x in the domain, there is one value in the range. So if I'm looking at a right here, f of x equals x squared, I notice that for these values in the domain, remember this is the domain over here, for each of these values, for example, if I plug in 1, 1 squared equals 1. If I plug in negative 1, negative 1 to the second power equals 1. If I plug in 0, it gives me 0, and so on. Okay, now in order to determine if each of these is a function or not, the basic rule that I have to make sure that it does not violate is that no number in the domain gets sent to two different values in the range. So what would that look like? Let's look at this example right here. Let's look at Dan. This again is the domain, and this is the range. And you notice for a function, it doesn't actually have to be specifically numbers that you plug in. It could be sort of any sort of information. In this case, Dan is assigned 1 phone number. Gizmo is assigned 1 phone number as well. Colleen, on the other hand, is assigned 2 phone numbers. Now that's an issue. This is what we cannot have. We cannot have a value in the domain being mapped to 2 different values in the range. And so therefore this one is not a function. Okay, now let's look at the other ones and let's kind of see whether or not those are functions, or more accurately, let's see why they are functions. Again, the one rule that you cannot that you need to follow for a function is that any value in the domain must be mapped to only one unique value in the range. So even though these two values are both being mapped to 1, if I'm just looking at this, it's only being mapped to one value, and this is also being mapped to one value. Same thing here. Each value in the domain is assigned to exactly one value. And even right here for D. You notice 0 is mapped to exactly one value, -2 is mapped to exactly one value, and 3 is mapped to exactly one value. Now, even though they're all mapped to the value 3, that does not violate what we have. That does not violate our rules for a function. That is still possible. The only rule, and again I repeat, the only rule that a function needs to essentially obey is any value in the domain cannot be mapped to two separate values in the range. And so each of these is a function except this one right here. All right, last thing I want to cover right here is a summary of what we just went over. So for a function, can any input, in other words, can any value in the domain have more than one output? No. What is the domain of a function? The domain of a function is the set of all inputs. There we go, the set of all inputs. And what is the range of a function? The range of a function is the set of all outputs. There we go. And last thing on this page is for a function y equals f of x, the variable x, which is your input, is also called the independent variable. So you might see this definition being thrown around sometimes. If you see the word independent variable, it's essentially your input. And the variable y is called the dependent variable. If you're wondering why they have these names, it's because if you think about it, the x can essentially be whatever you want it to be, and so it's independent. And then y, the value of y, depends on what x value you plugged in. Alright, and that is it for this video.